Hi, everybody. My name is Daniel, and this is our Encore uh, recording of our ASMS 2021 presentation on the GNPS dashboard. So, yeah, I used to be a postdoctoral researcher in the Dorstein lab at UC San Diego, and now, since a couple of months, have my own lab in Germany, in Tübingen. But what is probably most important for you is that I'm a mass spectrometrist, and I'm really excited about tandem mass spectrometry, and in particular for like metabolomics studies. So if we look at my typical day, so I spend some time here cleaning the instrument and like running samples, but I also of course have to like prepare samples, and most importantly probably have to like make sense of like the data, which obviously is like all done on a computer. If we put numbers on this, probably I just spent a little bit of my time actually like in the lab in front of the instrument, and probably most of my time in front of a computer analyzing this data. So now, fortunately, there is like a pretty big variety of like different software solutions for metabolomics data analysis, many of which we kind of like assemble in like this very colorful patchwork of data analysis pipelines. And yeah, fortunately, over the years, we typically become highly specialized metabolomics experts, and we master the magic of mass spec data analysis. So this data analysis typically includes, from like the beginning, data acquisition, data inspection, to then like processing, annotation, statistical prioritization and visualization, as well as like final validation of like our findings, and hopefully also data sharing that enables like reanalysis and reproducing our results by other researchers. So now, in my particular case, I came up with like this colorful mixture of different software tools, like starting with vendor software here for like data acquisition and then inspection, and then moving to like open format. Files, which we process with MZMine, and then annotate with GNPS, and then use like a mixture of different statistical scripts and also like software tools to prioritize features of interest, and then like visualize them, for example, in Cytoscape, before I then go back to vendor software to actually like inspect the raw data again and check how does the actual data look. Then the data sharing happens through Massive and also the GNPS environment. So now, while this pipeline works pretty well for myself, when we now think about how we communicate this pipeline and how we like interact with like other researchers, that thing which seems like very natural by now to me might not be like that intuitive anymore. So yeah, for example, like working with like a student, I have to make sure that they understand the same like software, that they have this installed, that they know like the right parameters, and yeah, it can be sometimes challenging. Now as a PI, even with like a bigger group of people, it becomes even more challenging, especially when people like have different preferences for different tools, or even like different like file formats from different like vendors. And I think it becomes especially challenging when we think about our interaction with the community. So here, having everybody being able to reproduce our data analysis, inspect our raw data, I think is quite a challenging task, which I think, for example, in peer review, like often like prevents like transparency and reproducibility by others. So now the most critical part there is probably like the final validation of data, which people, I think, especially for like the different like vendor formats, are kind of like locked down to like a certain file format. Then they have to have the software maybe like downloaded or converted to like an open viewer, and then like getting access to like this raw spectra or chromatograms. And I think this can span from at best a couple of minutes to like at worst like days or weeks till you get like a license of a particular program. And I think this significantly like limits like data transparency and like access to like simply like raw data others have used. So now, wouldn't it be awesome if we could just like take any LCMS or a mass spectrometry file and like just directly visualize like the most essential information, for example, like an XIC, like in the web browser. And I think this is really what the main idea of the GNPS dashboard was at the beginning. And after bugging Ming for long enough time, we started, or he started, like writing like software to like directly visualize XICs out of a molecular networking job, or directly out of like a file deposited in the massive mass spec repository. So now, yeah, what started as this like very, I think like little like application over the time has now become actually quite like an extensive software suite, where we have like various like input sources, so like multiple mass spec repository, including also like your own private file upload can be like pulled into the GNPS dashboard in your web browser, where you can inspect it. And from there, you can then also launch like analysis, for example, like feature finding, or molecular networking jobs, or repository scale spectrum searches. And I think most importantly, from there you can then also like share the different views and different analysis. So this can be either done with like a URL with like your peers in an email, or even in your paper, or it can also be done like actually in real time, when you like share like a completely synchronized session with your peers, and then like in a Google Doc style inspect like mass spectrometry data with your peers over on multiple computers. And yeah, I'm very happy to do this presentation together with Ming today, and he's gonna now, in the next couple of minutes, I'm gonna walk you through the details of the dashboard, and a couple of like applications, and how we think this might help you in doing your metabolomics data analysis, and particularly inspection.
Well, thank you, Danny. And you're standing right there so I can see you, for giving us a good introduction to the GNPS dashboard, and why it came into existence and what the need is. And I think one of my needs initially was out of laziness too, so I want to add that to the pile. I didn't want to download data, and I didn't want to install software. So for a lot of you bioinformaticians out there, hopefully you can relate. But I want to give you a little bit of background into the actual software and hardware infrastructure. And so the backend, Python web server, it's all open source. You can go download and run it on your own servers today. But more importantly, we want it to be part of this integrated ecosystem. And so we host it on our humble little servers. Right now it's on a 24-core workstation. And this seems to serve a lot of the community. We've been able to scale up to hundreds of users in our workshops simultaneously analyzing data. So this bodes well for bringing it into the classroom. As well as we've seen quite a bit of adoption over the past 7 months. So this is relatively a brand new tool. And about 18,000 LCMS runs analyzed, 123,000 unique visualizations, and I guess we got to correct this too, 4.1 thousand users. So we're really excited that the community has started using it. And so I want to walk through an example that Danny went through. Actually, he's went through this analysis process using the dashboard, and how it could have helped him, and hopefully you all can see parallels in your own work. And so just one particular example, Danny was analyzing a particular set of LCMS samples, and he created a molecular network. And so don't worry about the details of molecular network, but bottom line is he found a particular molecule that the structure is shown here, and he thought this was interesting and wanted to make sure right then and there that this was a real molecule. There was a real nice peak in the raw data. And so with just a few clicks, he was able to go from within GNPS, a molecular network, to looking at the extracted ion chromatogram in the GNPS dashboard. And so here, what was unique that he was able to see, not missing from the molecular network, is actually this molecule that he thought was one molecule is actually two chromatographically separated molecules that are resolved, and they're diastereomers. So by being able to go back and forth between the molecular network and the raw data and the extracted ion chromatograms, he was able to reveal that. And then secondly, within this experiment, it's actually a set of samples from a wild type and a knockout. And he was able to quickly see that the more quantitatively rather than qualitatively, that indeed within the wild type this molecule is present, and within the knockout it's completely gone. So simply being able to connect to the GNPS dashboard so easily, he's able to answer both of those questions pretty conclusively and very quickly. And one other small point that we want to add, just because he had originally done feature finding on this data, is we wanted to also lower the barrier to entry to do feature finding for the community in general. And again, we don't want this to be the end-all be-all solution to do feature finding, but for people that want to just get their feet wet and get something out that they can start analyzing, we've worked with the MZMine team, specifically Robin Schmidt, and we've integrated MZMine into the GNPS dashboard with a reduced set of parameters to make it easy to figure out the parameter sets that you need and immediately go over to GNPS and run MZMine on your data for a large number of samples. And also, kind of very naturally, when you're exploring untargeted mass spectra data, you look at MSMS spectra. And so if you look at MSMS spectra within the GNPS dashboard, one of the cool things that kind of added in when I was excited was the ability to integrate with this real-time library search across GNPS libraries, across proteomics spectral libraries, and pretty uniquely across all public data out there ever. So we're talking about a couple 100,000 spectra in the spectral libraries, all the way up to billions of spectra. So that's kind of exciting, and working with Nuno Bandeira and Ben Pullman to make that happen. And it does it even before you ask to do library search. It'll tell you, hey, there's 4 putative matches. Well, I didn't even ask, but now you're kind of curious. So we think that's kind of cool, this kind of pre-fetching, precognition kind of idea. But also, one of the key things that we wanted to bring across in the GNPS dashboard is how this visualization and sharing can really have payoffs in each of the different stages of the research lifecycle. And so during the research phase, as Danny kind of pointed out, you want to be able to share your data analyses with your collaborators, with your supervisors. And what's the game? It's the ability to quickly iterate on the data analysis, find issues with the data, find insight into the data that you wouldn't have otherwise if it weren't so easy, and hopefully that accelerates finding real things that are biologically meaningful. In the second part about the review phase, as Danny had mentioned, it's making it really easy for reviewers to actually inspect your analysis. And what does that do for you as both as an author and as a reviewer? Is it really makes sure that everybody puts their data out there, and it makes sure that it accelerates the data review of your manuscript. So everybody likes a faster review. And also at the end of the day, it'll hopefully find errors and facilitate corrections and improve manuscript data reliability. So it makes the community just better. And then finally, after publication and the data is deposited, what this enables is easy data reuse. You can go to any repository, find any file, and visualize it within seconds. And so this obviously makes it nice for, if you want to mine other people's data for corroborating evidence, as well as it facilitates teaching. So you can look at data across multiple different instrument vendors and kind of see similarities, differences, and just from an education perspective. And so I just want to also here talk about how we categorize data sharing in general and how we think about it. And so there's 2 dimensions that we think about across space and across time. And so if data is shared within the same time but across different space, that's real-time synchronization. 2 people or sets of people are looking at the data at the same time. So this is with a collaborator, a mentee, or a classroom full of students. But if it's across time and it's across but it's not across space, that means you're sharing with yourself. So maybe you want to remember a visualization that you're creating today that you don't want to have to totally recreate and remember tomorrow. Maybe it's with a collaborator. You just want to share it, that they can look at it on their own time. And it could also be with a journal reviewer. You want to communicate a particular finding and let them explore interactively so that you can convince them you are doing the absolute right thing. And so talking about asynchronous visualization, how we achieve this is one is we can generate URLs. For whatever visualization you're looking at within the GNPS browser, what kind of, zooming in, what kind of masses you're looking at, you can create a URL that includes everything that you're looking at right now, send it to somebody else, and they can recreate that analysis by simply clicking on that URL. And you can try it. There's this big QR code. Hopefully you at home with high enough resolution, you can actually see that. And so one of the cooler things that we wanted to show off is the synchronous communication. And so the way we tell others, it's called Google Docs, but for mass spec inspection and data analysis. So this was really, really fun when we first started implementing and thinking about it with Danny. And so one of the models that we offer is called this leader-follower synchronization. And so it's mostly we meant it for classroom teaching, but imagine you have a teacher and a class of students, and the teacher can change the visualizations and all the students are synchronized to the teacher. And so that's kind of cool. But what's particularly unique about this is because it's following along in their own browsers, they can choose to stop following and then explore on their own. So they can build upon this particular visualization. And then the second one that is even more exciting to us is this full synchronization. So this really embraces kind of the Google Docs kind of paradigm. You can imagine a set of 3 researchers in this particular example. They're all sitting, in different parts of the world. I actually was analyzing some data with Peter and Danny while on an airplane coming back from ASMS. So that was kind of fun. But all of you can change the visualization and it'll get automatically propagated bidirectionally to everybody else. And so these are the 2 synchronous modes that we hope will encourage education, data sharing, and just inspection in general. And so I want to kick it back to Danny, and he can talk a little bit about how it's really changed his work and kind of our vision on how we can change the field going forward.
Yeah, thanks a lot, Ming. So how has this changed my research so far? So I think looking at our days, probably the computer work is definitely not going to become less and probably even shift more towards that side. And working with the dashboard so far definitely made that interaction so much easier. It saved me so much time inspecting data from both collaborators and during peer review. So I think taken together, this really empowers our collaborations. It simplifies teaching. So I have not used it so much myself, other than for some workshops we did, but our coworkers that actually use it in the classroom are super excited about how easy it is to showcase mass spec data analysis to their student. And I think most importantly for myself, it really makes that data accessible during the peer review process, especially if people deposited their data in a repository. And I hope that the dashboard will contribute that way to more open science and a more transparent and reproducible data analysis of others during peer review, but also after publication. So with that, I would like to thank very much Peter and everybody in the Dorstein lab at UC San Diego, as well as everybody in the Bandera lab, and in particular our collaborator and former Dorstein lab member Vanessa Phelan in Colorado, and also all our beta testers and co-authors of the GNPS dashboard paper, which was also fortunately just accepted for publication. So now again, if you want to try it out, here's again the QR code or the URL. It's fairly straightforward. So please feel free and test it. And if you have any feedback, we would love to read it in the comments or shoot us an email. Let's get the conversation started. Thanks.